a 95% confidence interval for the GMAT scores. She knows the standard deviation is 113. She collects a simple random sample of 64 and computes a sample mean of 526 for the true GMAT score.
Isn't it 526?
Yeah.
Yeah?
I think so, because we're not given the actual one, so it should be that one, right?
Yeah. Because there's a similar question on the prep to that.
Yeah.
What is the margin of error for the 95% confidence interval for the true GMAT score? Okay, I'm confused because the next question says, what is the lower limit of this confidence interval?
Mm-hmm.
So is it not going to have us put the two numbers? Okay, I see. Because the next question 8 is what's the upper limit?
They do, yeah.
Okay, gotcha. So this one, number 6, is going to be just like the other one, but with 0.95, so 1.96. So we take 113 divided by the square root of 64 times 1.96. 27.685.
Got 27.685 for the margin of error, and that would just be that negative value for.
So I thought it was just the same thing that we did on question 3, but using the numbers that it gave us for this scenario.
Yeah. I think you're right. I'm not.
Yeah. I don't feel like 100% though. That's why I'm the margin of error.
$126. Then subtract the z-score. Do we have the z-score?
Yeah, the z-score is going to be the 1.96.
And then we're going to multiply with that. Let's see. Multiply it by the standard deviation, which is 113. And then divide by the square root of 64. What number did you get?
For 6? 27.685.
I don't know what I did wrong. I must have done something wrong.
Let's try doing this first. So 113 divided by the square root of 64. You can get that answer and then multiply it by 1.96.
So 113 divided by 64, and then we multiply.
Root 64.
Yes.
Okay.
And then we multiply it by
1.96.
which is our z-score, and then we subtract x from it, so our normal number, or do we just leave it there?
For number 6, I think we just leave it there.
Okay.
I'm gonna go to the textbook real quick to just double check. So it's asking for the margin of error, right?
Yeah. The margin of error has the formula is x take away z times the standard deviation over the square root of the number. So I'm thinking the upper limit would be our value of 526 minus the value that we just found of 27.685.
Yeah, I think so too. Do you
Okay.
think it would be the lower limit though, because it's going to be lower than adding it? Because if you add the 27.685, that's going to be a higher number.
Oh yeah,
To me,
so, right. So we need to add this time to get the upper limit.
Right.
Okay, I get 553.685.
Plus 526. 553? Yeah. So that's going to be the answer to number 8, right?
Yeah.
Okay.
No. Won't it be the answer for... Oh, I get it. Never mind. One sec. I get what we're doing now. Yeah.
So the lower limit will subtract the
Yes. So 8 is the number we just calculated.
So 498.315 is the lower limit.
Yeah, I got the same.
Cool. Okay. What would happen to the width of the confidence interval if Gina increased the sample size? I think this was on our homework.
It would decrease, right? Because then there's less error.
Uh-huh. Yep.
What would happen to the width of the confidence interval if Gina changed it to a 99% confidence?
It would increase.
Yeah. Okay. Bright Bulb Light Bulb Company is planning a study to assess the average life expectancy of their light bulbs. They know the standard deviation is 400 hours. They want a 95% confidence interval with a margin of error of 50 hours. What sample size do they need? Round to the nearest. So we're going to use our sample size formula. So we take our number that we're given. We're not given the numbers first. So we calculate what it is at a 95% confidence interval.
So the z-score is going to be the 1.96 still.
So 1.96, and then you're going to multiply it by the standard deviation, which is 400. That's a lot. And
Yeah.
then you divide it by the margin of error of 50 hours, and that should give us the number we need.
50. 10.08. So let's just double check. So if we were to take 400 divided by the square root of that answer, it would equal 125.98 times 1.96. I'm lost.
I think we should just go with 16. So that's the
16.
number you get out if you do the sample size formula.
Uh-huh.
So it should be 16.
So what was the formula again?
It's n, your number,
Uh-huh.
it equals, parentheses, the z-score times the standard deviation over the margin of error. Oh, and I have a little squared sign. Do we square it?
I have no idea. Did you get this formula from the
From the lesson,
text?
yeah. Let me go look. I don't remember the squared part. Oh yeah, so we have to square that number, so it's 16 squared. Which gives us 256.
Where is this formula so that I can copy it down?
Let's see, 1 second. It is under section 5 of the sample size calculations.
There we are. Wow. I feel like I didn't see this part of the textbook. What the heck? Because there it shows too the margin of error, z-score times standard deviation by the square root of the sample size.
Mm-hmm.
And then the sample size equals the z-score times standard deviation divided by the margin of error, which is 50, squared, 245.
What's 245? I got 256.
Oh.
So we want to know the sample size, and they gave us the equation that has the sample size as our result. So we just need to do our z-score of 1.96,
1.96
multiply that by 400.
times 400. That equals 74.
Yeah. No, 1.96 multiplied by 400 should be 784. 784.
That's what I got.
Okay. And then you divide that by 50, which is your margin of error.
And then
You square it.
15.68.
Yes, that's right. And then you need to square that.
So I got 245.
That's weird because I got 256.
Let's do it again together.
Okay.
At the
So
same time.
we need our
What?
z-score, which is 1.96, correct?
Yes.
Okay, so 1.96 multiplied by 400. Okay, I get 784.
Yes.
Okay.
Divide by 50.
Which would be 15.68.
And then squared. I still get 245.86. I think when you squared it, you squared it with 16. You rounded it.
I just squared 15.68. So
Really?
I take 15.68 and I raise it to the second power, which is the same as squaring. Oh, that time I must have done it with 16. Yeah, so.
Yeah, okay. I think I remember you saying that. No worries.
Okay, so then we round to the nearest whole number, which would mean 246.
Yes.
Awesome.
Okie dokie. 12. What is the lower limit of this 95% confidence interval? Okay, so we've got a mean of 100,000, standard deviation of 36,730. Your sample size is 36. Do we use the 111,000 or the 100,000?
Well, the actual test is 111,000. And 100,000
Right.
is the one they actually have, so I'm guessing it would be the 111,000.
Yeah, it is. I just checked in the textbook to see which mean they use.
Okay. So we need to
Okay.
find the z-score, right? With the 95% confidence interval?
Which it should just be the 0.96 again.
Yeah, it is.
Okay, so 1.96. Oh wait, I'm gonna do the 36,730 divided by the square root of 36 equals 6,121. I'm going to times it by the interval or the z-score. And then the lower limit, that means I'm going to
Means you're gonna
subtract the answer I get. Yeah, so 111,000 minus that answer. 99001.
Yeah. 990.
The nearest whole number, so it'd be 99002.
So 99002.
Right, because we had to round it.
What is it? So it's going to be the same thing except we're adding it to x.
Yes, 36. One, two, two, 998.
They sure have a range, don't they?
Yeah.
1.229. But you want to round it to the nearest whole number, so it's just 1?
Well, it's 122,998.
Oh, you said 1 point, and yeah, okay.
Sorry.
So it's 198.
Yes.
Okay. Good here. There are 3 requirements that need to be checked when computing a confidence interval for a mean. They are: a simple random sample was drawn from the population, the standard deviation is known, and the sample mean is normally distributed. I'd say all of the above.
It's all of the above, yeah. Okay, are we ready?
Yep. Let's do this. We got 96.43%, so we only missed half a point, which is good. So we missed the upper level.
Wait a second.
Did you get 100?
Yeah.
I accidentally hit a comma in between, so I'll just have to go and fix that, and then I'll have 100% too.
Oh, okay. Gosh, that scared me. I'm like, what?
Yeah, I just realized, oh, wait a second, there's a little comma in there. Okay.
Okay,
Awesome.
we're good. Well, you have a great time at the devotional.
I will. Get better soon.
Oh, it's just allergies. Thank you.
I wish that you could get better from allergies, but
I know, right?
go away. Yeah.
I know.
Okay. Thank you for meeting with me early.
Yeah,
very
of course.
nice.
We can do if you get out of class at basically we can just do the meeting whenever you get out of class and when you find a spot.
Okay, sounds good. So I get out of class at 12:30, so usually by 12:45 I can start.
Okay, yeah. Whenever you just text me the link, I know. Okay, let's roll.
Awesome, sounds good.
So
Thanks.
it doesn't have to be just one.
Okay,
But,
sounds good.
okay. Yeah.
All right. Bye.